Activity 312 access control here, folks. We're going to learn how to enable and restrict access to digital assets, learn about different file types, and use file hiding and encryption. So last time in this class, you were doing like Linux commands, and we were making a list for that. Learning a lot of this. Now we're going to learn about how to control some access to files, because there were things that were happening like deleting files and copying over files that maybe everyone shouldn't be able to do. My list from last time, I'm just kind of keeping a running list of everything that we learned. So if I learn stuff, this list, I think it's good. I'm not sure if we learned something today. We'll find out. So managing the permissions to access a resource is called access control. As a security specialist, you often manage access control, meaning you're in charge of who has the right to view or modify system resources. Access control should be based on need. Security specialists should determine or be told by the system owner who requires access to different parts of the system. In a Linux-based operating system, there are 3 types of entities: owners, groups, and everyone else. Okay, so like there's different permissions for different types of people. So like the owner of the file, whoever created it, and then like the group of people. What does group actually mean? Let's find out. For each entity, permissions are assigned, allowing different levels. Yeah. Oh, here you go. User owns a collection of users who have group access to file. So it might be like everyone at your, like, okay, everyone in your company or at your school. Like, do they have permissions to see the file? And then there's like everyone else in the world access. Okay. And you can either give them permission to read the file. That means actually like open up the file and see what's inside. To write. So write access is about either like editing the file or just replacing the file. And then execute. Execute is to run the file or go into a directory. So yeah, that's it's almost like read and execute, or like they get to do stuff with the file, but this would be like actually running something. And so maybe like a file that runs something on your computer, which could do a lot more than just reading a file. Like reading a file, you can just like, oh, you can see what's in there. You're like, oh, you can see the contents of the file. Like you're not going to do harm to the computer, the machine running it. Executing, if you run a program, it can do stuff on your computer. And you might not necessarily want everyone to be able to run that program, depending on what it does. So the way we control these is through like setting up this matrix. Like basically RW got like groups of 3 right here. You'll see how this goes later on. But we have the owner chunk, the group chunk, and then everyone else. And there's also going to be a character in the front. So the first character or of this permissions like line denotes whether the item is a directory or not. So directories are like the folders. Okay. So D is a directory, a dash is not a directory. Okay. So if I see so the permission matrix is just going to be like this 10 character thing right here. Okay. All right. There's a lot of intro to that, but let's see. We open the lab, blah, blah, blah. Let's go. And it is open. So the first thing we're going to do is double click the alpha shortcut in connections. So you're going to connections. We're going to open up alpha, because remember that gets into our Linux command right here. All right. First, go to your home directory and change directories to executables. You might be like, well, how do I do that again? Now I'm going to go to my Linux commands. And this is where it's important to write all this down. Even if you don't, maybe you want to have this on a physical piece of paper, your commands, because you're like, how do I go to my home directory? Well, you in your home directory right now, and if you do ls, that lists everything in there. And it says, hey, I want you to go into the executables directory. That's this one right here. And we had to go change directory or cd executables. Just like that. And so now I'm in here, and I can say ls again to list every file in there. Now notice some of these are green, and so this one's white. White was just like text or just like generic files. Green ones were executable files, if you remember. Like pink were pictures, and blue was directories. First, okay. To reduce the typing. Oh, it tells you what to do. You can use a shortcut feature built into the operating system. Oh, so you can start typing it and then hit tab, and then it'll just autofill the rest. Oh, that's cool. I'm actually going to try that. So what if I did CD and I said XA and I hit tab? Oh, cool. So it says, you know, if there's exe, if there's only like one option, you can just fill it out for you. Cool. So you don't have to worry about typing it all correctly. You may want to list the contents directory. I did that. To see permissions using the ls command, use the -l flag. Okay, so we're going to get a new thing. So I want to see the permissions of the message SSH file. So I'm going to do ls-l message SSH. -l message.ssh. Wait, what? Oh, I said SSH. SH. And there you go. So look at my permissions right here. There's some dashes and then there's some RWX thing, right? I'm actually going to add that to my list. Compare the permissions of the file to the permissions of the welcome text file in your home directory. All right, so that's how you did that. Now, if I want to do the welcome text file, I do that actually. Well, do I have to go back up a level and go ls-l welcome.text? So right here were the permissions for the message file, and right here were the permissions for my welcome file. Notice they don't have the D at the start, so they're not directories. The first chunk, if you don't remember, the first chunk was owner, group, and then others. And myself. So the owner of message can read, write, and execute the file. The group can only read and execute the file. They can't write over. And then the whole world can't do anything to it. But the welcome.txt file, everyone can read the file. There's 3 R's. And the owner can like rewrite the file. But there's no executes for anyone. And that makes sense because this is just a text file. There's nothing to execute. So there you go. So there are different permissions. Now describe the owner, group, and other permissions for each file. All right, so we can fill out this thing if I wanted to. I have it in the document. So the owner can, okay, so for message.ssh, the owner can read and write. What I would say is message.ssh. The group can read and execute, and then everyone can do nothing. So I would do like, you know, they can read and execute, and then there's nothing here. Something like that. I'd fill that out. All right. Now for the welcome.txt, I'm probably going to make a copy of this. Yeah, I'm just going to delete whatever I write. For the welcome.txt, I'm just going to fill it in here. In welcome.txt, what can it do? The owner can read and write. Not execute. There's no execute in there. The group can read, and then everyone can read. That's what we're writing down. Okay, now there was additional information in the -l reports. So if you remember this, there's like, okay, that 10 character chunk, and then 1 alpha alpha, this blah blah blah. What does all that mean? So so this first part they're telling you is the number of references in this file. This tells you the number of links and shortcuts to this file. So like if there's a bunch of other links around the system to this file, that's kind of weird. Okay, cool. The owner of the file is the first one, alpha. That's who I logged in as. The group, we call the group alpha too. Okay. The file size in bytes, so 28 bytes. And the date the file was last modified. Okay, the timestamp. So who owns message.ssh is going to be the first thing. Alpha owns message.ssh. Why do you think the color of the file name tells you? Okay, so alpha owns this, and the green said it's an executable file. I think we learned that last time. So I would write that stuff down. So alpha, and then green's your executable. Now that you know the message SSH is an executable, thank you for spoilers. Use the cat command to look at its contents and try to determine what it does. So how do you do this? Wow, they tell you right here. Just go cat message.ssh. So I have to go back in executables. And Now you can see it. So I'm going to go cat message.sh. And when I cat that, it says it gives this directory cat and then welcome. Huh? I guess, okay. Now that you know the message is an executable, use the cat command to look at its contents and try to determine what it does. Oh, this just actually, so it's an executable file, but when I cat, I'm just writing what's in the file. So this executes a command, and that so executes whatever commands are in there. And the only command is this one command in here, which will write out what's in the welcome file. That's what's going on here. So instead of executing it, it's just reading it. So that file, all it would do is just write out what's in welcome. Now execute it by typing the name of the file. So that was just, cat was just reading the file. Now I just want to actually execute it. So I'm going to go message.sh. So instead of it, so what it's going to actually do is cat the welcome file and says, welcome to your exploration of Unix. If you remember differently, I'm going to, maybe they do the next part. If I just wanted to cat welcome, I'm going to do the same exact thing. I move back up to that directory. Okay, cool. I'm going to add a command. I should add, or get past this. I'm going to add this. The -L flag list. What is it list again? Shows permissions. Shows permission and some other file information. Owner, group, size, class, and then it'll say timestamp. Okay, so wrote that down just in case I need it. All right, I'm going to go down. I'm down to step 8. Output is the same as if you ran cat.welcome text. Wow, okay, that's what I did too. When you execute this, it was as if you typed it yourself. Just like in Windows, you can write shell commands. So .sh is like a shell file. So that'll run some commands. Like if we're typing in the Linux terminal. Let's look at some other executable files. Get a list of the contents of executables directory and showing permissions and ownership. Oh, so if we do -ls-l, instead of just saying ls, if we say ls-l, oh, that's kind of cool. Okay, I want to take a screenshot of that. So that is going to show you, geez. That is going to show you everything in here. I wanna, oh. There's also ls-l. I'm gonna put that as a reminder. All right, just so I can have both available. All right, ls.file name. We can look at all these files. Notice that other file extensions are all different, but they're all executable files. So we had the message, question, and quote of the day. You know, the permissions could be different on these. They're all executable files. There we go. File types. All right. Unlike Windows, file extensions in Linux do not determine file type. Instead, the operating system manages file types directly. Users cannot change file types in Linux like they can in Windows. This is one reason that Linux-based operating systems are more often used to secure network environments. I zoned out when I said that. Instead, the file extensions do not determine the type. Oh, okay. Like, because you can like rename a file and just like ever just try to rename like a picture file like a JPEG to a .txt. Like you can do it, then I'll just open it as a text file. But Linux won't let you do that. You can't just change file types just by renaming it. That's what makes it more secure in some ways. That's why secure network environments. Okay, that's neat. Linux provides a file command that reports file types. First, use it to learn more about message.ssh. So file and then file. Okay. A file message.sh. File. It's an ask message is ASCII text. Okay. Reports that it's ASCII text. ASCII is, it's just text. It's kind of like the standard text system most computers are going to be using. Ever heard of ASCII art? It's where they make art out of a bunch of text. Change the extension. Move the file to message doc and rerun the file command. Move the file to message and rerun the file command. To change the extension, move the file to message doc. Really? And rerun the file command. So, okay, I'm turning it to a message. So remember how to move. We go mv message.sh. We can move it to message.doc. Notice it's message.doc, and let's rerun this file command. So we're going to go file message. Like, I renamed the extension. That should be a document, right? It says error cannot. .doc. And notice when I open message.doc, it says it's still ASCII text. As you see, changing the extension does not have any effect on the file. So I am going to add this to my list of commands. File. And like, what did this do? This told me what type of file it is. Right? Where is it? Go. Tells what type of file is. Doesn't it do that? Something like that? What did it say? File types. Sure. Determine the file types of all of the other files in the executables directory. Instead of typing each file name, use an asterisk. This acts as a wildcard. So what I could do is go in here and go file asterisk, and it'll just print out everything. And then it said message.doc is ASCII text, and question.exe is this thingy, for the day is this thingy, and trust me is ASCII text. Okay. While two of the file types have very long descriptions, can you briefly summarize what the file types are? Okay, so here you go. Spoilers. ELF 64-bit, whatever. These are executable files. What are the types of files in Alpha's home directory, in the pictures directory? Alpha's home directory. Let's see. So we're going to go CD, just go back home. And then we can go file and then star. And there. It's a bunch of directory files with one ASCII text. Cool. I would say that. Bunch of directories and ASCII text. All right, are we getting close to this end? Speed up, dude. All right, let's recall how Windows handles file types. Return to the login machine, open File Explorer. Okay, file, we've done this before. Skipping that. A security scenario. As a security expert, you've been contacted by a user of your system, username Beta, suspects the system is infected with malware. You review user's shell commands to try to trace the problem. Analyze each of the user's actions and try to predict any suspicious or unsafe events. Okay, so here's some scenarios. They said print working directory, downloads, and they listed this. What were the actions? They did pwd. They navigated to their home directory and downloads, and they listed the contents of this, and they found an executable called puppy image. Now, this might be a problem because why is this an executable, but it says it's an image file? It's strange to find that. So that's one of those things you go, huh, why would that be an executable? Next thing. So they catted the puppy image and said, oh, it went to security check. And then you listed everything in here. And then it found this thing. This looks like a directory. Or, okay. So catted the puppy image to see what was in it. Or what the executable does. And then it goes to bin security check where the user listed the referenced file. It's also an executable file. So what's suspicious? Why does this look like it's bin slash that? That's kind of weird. It looks like it's a directory type thing. So it's one of those like you're kind of hiding names within what's going on. It downloaded. So it checked puppy image. What was this thing again? I don't remember. Remember this from last unit? So, if you execute it, what is it going to do? It does what is it doing right here? This is a very unsafe action, a big mistake. Okay, so yeah, executing a random file on your computer is not a good call. And so it did some stuff. And it looks like it was just printing out like process IDs. Remember that kind of stuff we did before? That's not good to do. So there's the analysis. Let's look at hidden files. As in Windows, sometimes you want to hide or encrypt files. So we can still hide files. You haven't seen any hidden files yet, but you actually have some in your home directory. Hidden files begin with a period and are not normally shown in the ls command. You can see that with the -a flag. Okay. Now let's do ls with the -a. So we go ls-a. Ooh. Okay, there's my new command. So I'm going to add another thing to this insert row below. ls-a. The -a flag lists all files, including hidden files. Okay. You see a handful of new files. Boom. A lot of new things there. You can combine ls flags with an A and an L to see the long list of all files. So what if I want to do multiple flags? I can do a -L and a -A, or I can do -LA. Well, that's kind of cool. So I can go ls-LA and it'll list everything with the details. Or I could have gone ls-L and then done a -A. Same command, but just a little shortcut. All right, hidden files behave just like ordinary files. The only difference, they don't appear in the result of an ls command. But, it's not hidden very well if you just do a -A. Encryption, change the directories. The Linux-based operating system has a few different encryption commands. One of the most secure is GPG. Change the directory to your info directory and list the contents. So we're going to go to inside info and list the contents. It says just email addresses. You want to keep this file. It's a file. Yep. The file is very private, so you decide to encrypt it. Let's see, because what's in here? Email. Oh, yep, that's what's in there. Just so I was curious. You want to keep the file private, so you encrypt it. You can do this with the GPG command. GPG is it's just some program on your computer. Open source. That means it's free. It's publicly available for free. Cool. And that freely available GPG is new privacy guard. Okay, so we're gonna do this GPG-C email addresses, right? GPG-C. I'm gonna use the tab. This is so much easier when you use tab. All right, and then it's the first time you run it with C for create. You see the output telling you it created this in your home directory. It's gonna ask you to create a passphrase and confirm it. Passphrase. I'm gonna call it password because notice when you do passwords. Oh, invalid passphrase. What? Password T. Oh, I just didn't type it the same thing twice. When you type, when they're doing passwords in like Linux, they're not going to put asterisks up. They hide that for security. So stuff was actually happening, but they try to be a little bit more secure. All right, so I password protected it there. Remove the original file. Confirm the removing file is the one that was generated by... Okay, so what did I do next? So if I do ls... Oh, now there's this one that's password protected. Now I'm going to remove email addresses. Remember, RM removes it. And now I just have the encrypted file. The GPG file. All right. Confirm the remaining file is the only one left. What's the file extension? Is GPG. Using GPG with a -d decrypt command, along with encrypted file name to decrypt the file, you need your encrypted password. So I can go GPG -d to decrypt, then email addresses, and password key. Oh. Okay, it was not integrity protected. Whatever, I did it. And I think that should have just opened it, right? Oh, it opened up the file. Okay. So cool, we're done. I did that one. -GPG. I'm going to add this to my commands. Another scenario. Consider the following scenario. From a valid and secure website, you downloaded some files that contain sensitive corporate info. You want to make them as secure as possible. The files are year 1, year 2, year 3, etc. Secure them. Relocate them to a subdirectory. And encrypt them so that only the encrypted version remains. List and describe all the commands you use in the mini scenario. All right. I'm going to leave this up to you to do. Because I don't think I should spoiler everything. Why don't you try that? And that's it. Thank you, folks.